These students asked me the final paper is an extension of the midterm paper. Yes, the final paper is the extension of the midterm paper. So you may include any part of your the question like this. It's just an instant message, so I cannot read it so quickly. So why don't you put it in the question part? So you may take any parts of your midterm paper into your final paper, but as I already posted, the final paper's topic is the deep hedging on Asian options. And I'm going to tell you what Asian option is, and I'm going to give you lots of hints for the final project. So please watch it carefully. Okay, so the midterm is about 8 pages, but I want you to have the at least 15 page for the final report. So you may add some more the additional materials at the end of your midterm paper, but I think my recommendation is you better write your whole final paper, because that is, if you wanted to explain the Asian options and what do you mean by the delta hedging or deep hedging, then you will probably need more than 15 pages. So that's why we are here today. I'm gonna give you lots of information on the Asian options, and once you understand today's lecture, there will be no difficulty to finish your final project. Okay, the grading. Okay, so if you pass the midterm exam and you finished all your homeworks, then you are guaranteed to have B+. So I'm gonna write it down here. So if you have done all of your requirements so far, you are guaranteed to have B+. Then how can you get the A+? It's a final on time. And if you are late, then you are going to have A-. And if you're really, really late, what I mean by the really, really late is I have specific dates, a specific date to have to enter your grades. So if you passed on the last date, then you are going to have, it's A0, and you're going to have A-. So this is the this is late submission, and this is your last submission. And if you fail to submit your final report, then you'll get B+. So midterm, final, okay. And midterm, final, and 17, because I accept one missing assignment, you can still have the A+, even if you miss the one. Okay. No, so late submission. So this, point 17 is okay, but late submission, you will lose one more point. So if you want to include your Python code, you can add your Python code at the end of your paper in the appendix, but not in the main contents. So basically, it's really simple to make it over 15 pages, because there must be lots of code. So don't worry about the the length of the problem, but I will judge based on what you have written on your final paper. Yeah, it's okay. Yeah, if you write in Korean, yeah, that's fine. I want to finish it in less than 3 hours, but I think I expect about 2 hours for today's lecture. And if you do not have enough time, then you may go out, because I'm going to upload the recorded version of this video, this lecture. So yeah, I hope, yeah, I can finish within 3 hours. Yeah, the final paper is about the deep hedging on Asian options. So first, you need to know what is the delta hedging and what is the deep hedging, which are today's topic. And after about 1 hour, I also explained about the Asian options. And Asian option, once you understand the basics of Asian options, it's just the options. But you need 2 more things to write your paper. The first one is how can you price the Asian options. That's the one part. That should be one part of your paper. And how can you do a deep hedging on Asian options? That will be your second part of your final paper. So I want to see the general understanding of your lecture, and then also see whether your calculation of the Asian option is correct, and whether your deep hedging of the Asian option is correct. So that is the grading criteria. Oh, sure, yeah, I will. But I already shared one colab, and that will be the. Okay, yeah, I will. Okay, I'm going to send it right now. So it's let's see, I want to share. So it's on the chatting, so you can copy the first link, and there is also another link for another collab. So I'm going to copy and paste. So these 2 collab is the could you give me a second, because I cannot find the screen. Oh, okay, it's right here. Okay, so I share the collab links. Okay, his question is the 13. So deep hedging 1 is to is about the D1. How can we define D1 from Black-Scholes? And so we calculate the delta, and using the delta, we calculate the cost. That's right. And then the 14th, so which is deep hedging 2 and 3, is use the TensorFlow to replace that delta hedging part. So you don't need to define D. and which is necessary for Asian options. So as I explain it later, the Asian option does not have a delta, does not have explicit form of the delta. So there is no ND1 like the call option here. So you need to use the deep hedging to price the options. So this is correct. Yes, Asian option, the code for the Asian option is, you have to write it down for yourself. But I will explain what Asian option is, and it will be just a little bit modification of the code. Yes, if you wanna, okay, for the final, for the midterm report, I accept the copy or the screenshot. Yeah, I accept almost everything. But for the final report, I wanted to have something really scholastic. So you have to make every graph for yourself and every tables for yourself. And if you write the code, a graph, yeah, you have to do it by yourself. So you have to redraw everything. So that's why I recommend you to do it in your midterm, because anyway, you are gonna draw the everything. Oh, I think, yeah, I answered this. Let's answer it. Okay. Okay, I will explain it. Yeah, why should I put delta at the end? But it's not true, because at the end, delta is either 1 or 0. So yeah, this is not correct. Oh, I think, yeah, this is the for the last week. Okay, so I'm going to delete all of them. Delete all. Yes. Okay, so I'm going to start with the this colab. So it's a deep hedging spring 2022. This is much like a simplified version of the previous collab. So it looks very long, but it's not so complicated. So you may try to run this code with the delta hedging Notion page. So this is what I'm going to do. I'm going to explain today. So first, I want to show you how can we make the different path of the stock price. And then I'm going to show you how can we use the generated stock price to replicate a portfolio. And then I'm going to explain the meaning of the delta. And then we can view this replicating portfolio in two different ways. So that's why I said, yeah, there are two versions. And this is just a little bit modification of the previous equations. And these are coded in Python. And then once you understand the last formula, then it is just a translation from your Python code with the delta hedging to a TensorFlow code for deep hedging. So that's the basically what I want to, that is the basic thing that I wanted to do today for the first 1 hour. And then after a short break, I'm going to explain the Asian options and how can we price them and how can we, I'm going to give you some hints for the deep hedging. So first, simulation. is to generate this path. And it is written here. So we import the NumPy and we import matplotlib, and there is one more Python package we need to we are going to use. It's from scipy.stats, and basically that's for the normal distribution. So these three are just the inputting the necessary modules. So I'm going to run it. And then under the title setup, there are two columns, and these two columns is for the basic assumptions of the model. So R is 0. I assume the interest rate is 0, and sigma is the volatility of the underlying asset, which is 20%, I assume. And the T is the time to maturity in years. So I assume that the time to maturity is 30 days, but I need to express it in years, so it is divided by 365. And here is M and N. So what is M? M is the number of a path in this graph. So M100 means I'm going to generate 100 different paths. And 30 here means this one, for one scenarios, I'm going to divide the one scenario into 30 different steps. If you increase the number of steps, it will be more accurate, but it takes more time. And if you increase the number of scenarios, it will be more accurate, but it will also requires much more time. So I just set the number 130, and you can play with that. And here dt and rdt is just for variables. These are just for variables for later use. So in order to generate the random in order to generate the underlying asset price, we need a random number, and this is the formula. And if you really curious about why you need, okay. Okay, yeah. Here is another link, the simulation basic. So if you are curious why we have this formula, you can go back to the original formulation and the discrete version and what it means by these notations, and then some modifications so that we arrive at the final expressions. So we generate lots of random numbers. So S0 is the current price of the underlying assets, and we assume the 20% interest rate, and we assume that there is we assume that 0% interest rate, which makes our calculation much easier, and then the volatility is 20%, and the time to maturity is 1 month. And here is MP random seed. It's just a maybe you can think about it as a it's just a seed. So if you use the same seed as mine, then every random number will be generated exactly exactly same as my generations. So this is just the today's date. So we can generate random numbers. And then for I is in range M. And remember that M is the number of scenarios. So in this way, we can generate 100 scenarios. And this is the formula for this part. And to see what's inside, let me take just one scenario. The scenario number is 0. And then print all the scenarios. Then it starts from the 100, and then it goes up, and down, and at last it will arrive at 63. So that's scenario 0. And if I wanted to scenario 1, then there is another sequence of underlying asset, and I have these numbers up to 99 because I generated 100 different scenarios. So it starts from number 0, and the last number is 99. So 99 is this one. And then I can make a plot. So this plot is in the node. This is exactly the same because I use the same random seed. Okay, any questions so far? Okay, there is no question. So just try to remember this cell. Then once you understand this cell, then everything will be much more clear. So the small m is 1. So that means I choose not the first scenario, the second scenario. So if you choose different numbers, the result will be different. But if you choose this one as 1, and you will get exactly the same result. And K is 100. So start price, no, the strike price is 100. And there are two variables. So one is called hedge. The other one is called a cost. So what I'm going to do here is to make a code for this formula. So here, S0, S1, and up to ST. So this whole sequence is just a one scenario, and S0 is 100, and S1 is some other number, S2 is some other number, and at the end, we will have ST. And there is a delta 0, delta 1, 1, 2, 3, and up to delta t minus 1. And I started with 0 and end up with 0. So you may think this one is a way of replicating a certain position. What I mean by that is for J is in range n. So remember the n is 30. So S0 is 100 is this number. And then S1, S2, S3. So all we need is to calculate the delta at each time. And you don't have to know what delta means at this point of time, but this is just a formula. So delta is norm.cdf of D1, and D1 is just a certain formula. So let me do it one by one. So J is 0 at the beginning, and I have delta. So I wanted to calculate the first term here. So I have delta 0, and this 0 is a variable named hedge. So hedge was 0 here. So delta minus hedge. So the selected part is delta 0 minus 0 times the stop price, which is 100. So we first calculate this part, which corresponds to the first term. of this one. And this whole, the first term will be saved in a variable cost. So cost was originally 0, and cost, the 0 plus the first term is saved in a variable named cost. So at this moment, the cost has the first term. And then for later use, we replace the delta, we replace the hedge with delta, because in the second term, as you can see here, it's a delta minus previous delta. So I call the previous delta as hedge. So this one is delta minus hedge times the stock price. And the sum of these two will be a cost. And then we are doing the same thing again and again up to the final point. So this is the code. So first M is 1. So I selected the scenario 1. And the strike price is 100. And now you know the meaning of the hedge and cost. Cost will be eventually the sum of all these numbers. That's our goal, to calculate the whole number. Mute. So at the beginning, the cost is 0, and hedge will be the second arguments in each parenthesis. So the second argument is at the beginning, it's 0, and then, or you may think the second argument as the previous delta. So at the beginning, there is nothing. So the previous delta is 0, and at time is 1. Previous delta is delta 0, and when time is t minus 1, previous delta is delta t minus 2. And at the final step, at time t, the previous delta is delta t minus 1. So that's the meaning of this hedge. So here we have a delta minus previous delta, which is hedge, times the stock price, and then add them up to the final point. And for each time step, I print this value. So the first one is the current stock price. The second term is the delta. So delta is 0.51, and cost is the sum of this formula for the first one, and second one. The second row has the sum of the first two terms, and third row have the sum of the three terms. So as you can see, the stock price are changing according to some random number, and also delta 0 and delta 1, 2 are changing, because delta is a value provided by the Black-Scholes. So every time the delta are changing. So what we are going to do is the delta hedging means we wanted to maintain exactly the delta positions at every time step. So at t is equal to 0, Black-Scholes tells us, Black-Scholes formula tells us the delta is 0.51. So that means I need to have 0.51 stocks. And the current stock price is 100. So how much does it cost? It's 100 times 0.51, which is $51. So I need $51. But since we assume that interest rate is 0, we can borrow $51 from a bank and make this amount of delta position. And then at time is equal to 1, the price has been changed to this value. So we are going to have a new delta. And this time the new delta is a little bit smaller than the previous one. But Black-Scholes formula tells us that you need to keep this amount of delta. So that means I need to sell some parts. How much? Delta minus previous delta, which is 0.15 minus 0.94, which is about 0.02. At what price? At this price. So my total cost will be this amount. So at t is equal to 1, it costs 51, but at t is equal to 1, it costs 94 because I sold some part of my positions. And at time is equal to 2, the stock price has been changed, and we have a new delta. And the new delta is smaller than the previous delta. That means I need to sell some more. So the total cost so far is just $42 because once I get the cash, then I put it back to the bank. So total cost so far is 42. And you are going to do this again and again at the until the final step. And the final step says the total cost is 1.95. So that's the way we calculate this formula. And what I wanted to show next is that what does it mean to replicate these equations? So in order to see what that means, this part is exactly the same in the previous cell, but now we wanted to test it for every scenarios. So that's why I have the scenario. I have this for statement. So M is 100. So for scenario 0, I calculate the cost. For scenario 0, I calculate the cost. For scenario 1, I calculate the cost. For scenario 2, I calculate the cost, and then save it to a variable named A. And then finally, I'm going to draw a certain graph. And that certain graph is this one. So it means on the x-axis, it is the final point, the final stop price. And on the y-axis, it's cost. So before I do this one, I'm going to make the second one as a comment. And this one is one. So this is the one that I wanted to show you. So remember that. Okay, it's all the cost. And the final one is this 0 minus hedge, 0 minus previous hedge, because at the end, it's 0 minus previous hedge times the current stock price, the final maturity times stock price. So when I run it, I have a payoff like this. So let me think about in this way. This formula is given by Black-Scholes, and Black-Scholes formula tells me that you just need to follow these procedures, and at the end, you will replicate a certain option positions, and this certain option position is a short position of the call options. So remember that. This is 0, and this is the underlying asset, and this looks like a short position of the call option. Okay, I have a question here. Okay, what does the formula for ST means? So ST is the stock price, and SIG is called a volatility, and it measures how much the stock price will fluctuate. Okay, n is not defined. So why you cannot have this? Because probably you did not run this part, because n is 30 here. So you should have n. So we just go to the link that I gave you. Okay, this one. Okay, I'm gonna share this one again, and then send it to you. It's on the chatting. So import the necessary libraries, and then define some variables, and then make a random number. And then this is actually making the 100 scenarios, because m is 100. And you can pick whatever number you want. So say 0th, then you will have a sequence of, actually this is total 31 sequence of numbers, which represent just one particular path of a stock. And when you use all 100 paths, then it will looks like this. Okay. Okay, what is a delta and what is hedge? Then you need to go back to the first video. So what I mean by hedge and what I mean by replicate, and when do we call something as a delta? That was everything, that was before the midterm. I believe that all of you remember that this example, it was 9 and 22 0 and 22 11. So the main focus before the midterm is how can we calculate this question mark. Or in the CRR option pricing model, it was something like this: S U times S. It's U times S, and it's D times S. 1, it's R. Of course, this R is 1 plus the interest rate, which is different from our current code. Our current code, the R is just the interest rate, but in the CRR model, the R is 1 plus the interest rate. And we want to calculate this C. So what we have done in the CRR model, we calculate the delta. Remember that? Yeah. So S times delta plus 1 times R. So we want to make this one is we want to make this one is to be CU and DS delta plus 1 R is going to be CD. And then all the calculation gives us the value delta. And this is exactly the same delta in the code. So delta is the position you need to keep in order to replicate the right-hand side. So that's the meaning of the delta. Okay, I will explain it, because I have not done this part yet. So I just said that, this is just the I just explained the first lines, because you need to differentiate between the first line and second line. And I have not done the second line yet. So the first line, and I called it a replicating certain positions. So the resulting replicating position is this one. So that is the magic. So the delta hedging is a way, so we said delta hedging, but the hedging is just the another side of replication. So in this example, I showed you how can you replicate the short position in call options, and why this happens to be a call option is that because of this delta. If you change this delta to a different number, then you can replicate put options. And if you replace this delta part with some other values, then you might be able to replicate Asian options. In this case, how can you know that this is the replication of the call option? Is that's because from the Black-Scholes. So I have not explained yet, but I will explain what it means. Yeah, but here we just since this is the delta of a call option, it happens to be the short position of the call option. And I think that's a very good question. So delta 0 minus s delta 0 minus 0 times s0 is the not just the first two. Okay, yeah. So, okay, let me count how many terms we have here. So it's delta 0, so it's 0 and 1 and up to the t is 30. So it's 30 minus 1, it's 29. So total, this is 30 and 31 terms. So there are 31 terms here. And in here, I choose the scenario 1, number 1. And this is S0. So this 51.14 is delta 0 minus 0 times S0. And on the second line, there is 49. This is the sum. This is the sum of first two terms. So basically, your understanding is, correct. So the first row is, this is S0, this is delta 0, and this is S0 minus 0 times S0. Okay, this is delta 0. I'm going to write it. So delta 0 minus 0 times S0 is the first term, and delta 0 is 0.510, and it's 100. So this whole thing is 51. And the second term is, in the notation, second term is delta 1 minus delta 0 times S1. And in the numerical value, it's So we calculate the new delta 1, and delta 0 comes from here. And then this is the new stop price. So that means I need to sell some portion of the stock at this price. That means I can get a cash. Then I repay back to this amount to the bank. Then the total sum is 49. Is 49. And you do this thing until you have until you reach the maturity date. Okay. Yes, yeah, you are. Okay, there are two things. The cell under the replication is just a one particular scenario with 31 numbers. And then we iterate from 0 to 99 for 100 different scenarios to the 100 different things. So the total number of points here should be 100. But I don't know yet which one corresponds to which scenarios. But as you can see, if you change the scenario numbers, so for example, this is 3, then final cost is 106. Then that would be about 106, and that point is around here, probably -4 or something. So it's -4 or something. Well, then you can watch the video. So this code is for deep hedging options in general, and for the final paper, we have to manipulate this code for certification options. Yes, that's right. Yeah. So I want you to understand this code. Then you just make some modification of this code, and then you can submit it as your final report. So why H is the previous delta? Well, that's because I divide it as this. So if you want to change, if you want to have different names, then that's fine. So instead of having a H, I can say it's QQQ. Then you need to replace this part as QQQ, and replace this part as QQQ, and replace this part as QQQ. Oh, QQQ. And then you can still have the same numbers. So for convenience, I just said, this is the hedge. HE. So may I may use the variable name previous hedge, but for some reason, I want to use this variable name hedge. Okay. Okay, this is the part that I need to explain, because I just wanted to show you that this line is a way to replicate a certain option positions. And if, of course, if you change this delta with some other things, then you can also replicate put options. Okay. So now, think about in this way. You are able, you know how much you need to buy or sell to replicate or short positions of a call option. The answer is here. Just calculate the delta. I don't know how we can calculate the delta, but it says, there is a formula. So if you know how to calculate the delta, then all you need to do is to try to keep your delta positions. And every scenario, if you face or lots of different scenarios, you will end up with replicating or short positions. So once you follow this rule, you are able to replicate a short position of a call option, which means you can sell the options. So let me go to this point a little bit more. So you are in a bank, and there is a certain customer. Let's say there is some company, say A, and this company, for some reason, this company wanted to have a call option. That means this company A wanted to have these positions. So as a banker, you can say, okay, I'm going to sell the call options. Or you may say, oh, no, we cannot do that. But as a banker, you'd better say, okay, since you wanted to have the long position, I am happy to have a short position. But now you can replicate this part. So if you do nothing on the hedging part, you are, you may say, if you do nothing, then you are in a naked position. So you have to lose some money or gain some money. But since you are able to short, by adding your ability to replicate this, this part with a long position, you can have the second line of code. So I change so I make the first cost, the first line of cost into a comment, and instead of that, I use, okay, this is the replication of a short position, and then here is a NP maximum S minus K and 0, which is a long position of a call option. And then when I run this part, it doesn't, it looks like it doesn't have a shape. But if you read it carefully, the every number is okay. First of all, the x-axis is still the underlying asset, and y-axis is from 1.5 up to 3.25. So if I magnify this graph, it will looks like this. It will looks like, so here is 90, 100, 20. It's just some value around here. And that value is the price of options. So it's around 2.2 say 7 or 8. So how can you verify this is the correct number? So in the next cell, we have a Blackjack formula. So here is a definition. So I define a function called BS call, which is the Blackjack formula for the call option. And this is the option for the put option. So, and this is just a formula. So I define the BS call and then put the specific numbers. So S0 is 100, strike price, K is 100, time to maturity is this, and this is the interest rate, and this is the volatility of the underlying asset. And the BS core set is 2.28, which means this call option. So let me go back to the first part. So I can make the short position of this option, and the price of this option is 2.28. How can I know that? I use the second part. So this is the short position of my call option, and this is the call option's payoff. And then if I take the real price, 2.28, then everything is around 0. So that's why that's the way I can replicate my portfolio. Okay. So what does sigma volatility means? Does that mean the level of fluctuation of the current stock price? Yeah, that's the, very similar. Yeah, it's the standard deviation of the log return. Okay. Okay, this is 3 o'clock. So we're gonna have 10-minute break. And then we will be back we will start it again at 3:10. So we will start it again. 3, 3. Uh, 3:10 p.m. Okay. Please. Oh, this is just the payoff of the option. So remember that this is just a max ST minus K and 0. So this is the call option. I don't understand your questions. If you do not miss any homework, if you do not miss any homework, and if you did the midterm, and if you don't wanna if you don't wanna submit the final, the maximum you will get is B+. Okay, so now let's talk about the meaning of the delta. We already know the binomial option pricing formula. It's something like yeah, I don't want to write all the formulas again, but if you remember the CRR paper, then it looks like this. And as I said, when n goes to infinity, this formula will go to this formula, which is a Black-Scholes formula. So here, D1 looks a little bit complicated, but it's just a formula over K plus R plus 1 over P minus T over sigma P minus T. So ST is the current stock price, K is the strike price, R is the interest rate, and capital T minus small t is the time to maturity, and sigma is the volatility of the underlying asset. So which is usually estimated from historical data set. And here ND1 means this is some normal distribution, standard normal distribution, and D1, once you plug in every numbers here, then you will get some numbers, say 2.7. Then ND1 means the area less than 2.7. So in general, this is D1. And you can also calculate the D2 very similarly. So D2 is everything is same, but just this part is negative. This part is negative instead of positive plus. gamma square root of p minus t. So you can calculate the D1, you can calculate the D2, and you can also plug in D1 and D2 in the calculator so that you have ND1 and ND2. And once you have ND1 and ND2, you can plug in ND1 and ND2. Here you can get the price of a call option. So the meaning of delta is actually the formal definition of the delta is this one. It's a partial derivative of option price with respect to the underlying assets. Then it seems like, yeah, you should be able to do the differentiations, but the answer is already known. So for this one, the answer is just ND1. This is the answer. So let's go back to the code again. So here is D1. And this is just the code for the D1. And then delta is calculated as CDF of the standard normal distribution with the value of D1. So this is just the mathematical meaning of the delta. And the physical meaning of delta is the position you need to keep to replicate your positions. So how can I keep these positions? By selling or buying the underlying assets. And the cumulative cost is actually the cost of the cumulative cost is the without adding the payoff. It is a replication of a certain position, and if you add the payoff of that, and then that would be the price of your options. So here, yeah, the actual the version 1 and version 2, you can read these two versions. These two are actually the same thing, but I just wanted to manipulate the order of the formula. So the first one, we start with the replication of a short call option, and formula looks like this, and then we add a long call option. Then here is the part plus max ST minus K. And when ST is greater than K, then this formula looks like this. And ST is less than K, then this formula is this. And there is a way to combine these two formulas in one format. And this is just the exercise. Then you can rewrite everything in this form. So this is the version 2 of the delta hedging. So delta hedging version 1 is just a Python code representation of the first formula, and version 2 is the Python code of the second formula. So we can still get exactly the same diagrams. And I did the same thing here. So the most important part here is that since this is just a plain vanilla call option and put options, we are able to get the delta. But what if we cannot get the delta explicitly? So that's where deep hedging comes in. In this case, we are able to calculate the delta. So by just explicitly calculating delta, we can replicate certain positions. But some options does not have the explicit pricing formula. So one example is the Asian option. It does not have the pricing formula. Since this option does not have a pricing formula, you cannot differentiate it. So that means you cannot calculate the delta. So there is no delta for these options. But still, with deep hedging, we can replicate these Asian options. So before we go into the Asian options, we wanted to see what do I mean by deep hedging? So deep hedging is basically replace this part with a neural network. Yeah, so neural network, yeah, looks like this. So do you remember when you do the data camp? Yeah, there are lots of explanations about the neural network. So just compare these two. So in order to calculate mathematically ND1, we need 5 numbers. Then this formula gives us some value. So what about the neural network? So what if we can give these numbers into the neural network and then find just one value? For our current problems, actually, we don't need to do this part because we already know the formula. But sometimes we need some more information, or sometimes the original motivation is, what if we add transaction cost in this formula? And there is no formula when we consider the transaction cost in hedging. There is no formula for the delta, but the deep hedging authors think about, what if we just put the transaction cost also inside the neural network models, then we can better hedge the options. That was the original idea. So let's just compare the neural network part and our pricing formula, the delta hedging formula. So it looks really complicated on the neural network part, but actually it's not so complicated because I just named the hedge cost and price. So we also need a hedge cost. So in here, its name is cost and its name is price, but here it's hedge cost and hedge price. And for example, I just make 3 steps instead of general n steps. So this is the layer we calculate the delta, and actually, as you can see, it's TF Keras layers dense instead of this formula. So this is actually neural network, and all the other parts is, since the TensorFlow is not so capable of doing this kind of calculations. For example, the cost plus delta plus price minus something, it is not possible to this part. It is just separated into new names. So for example, the subtract and multiply and add. So it's too narrow, but right here. In Python code, the cost part is cost plus delta price S. times price minus S. So in Python, yeah, we can write it in just one line, but TensorFlow can take only two values. So for example, yeah, we just take the price and ST and make a subtract layer. Then this one is calculated. And then the multiply layer is needed to calculate, yeah, this one and delta. So this is 2. And to add these two values, so it has add cost plus 2. So these 3 lines of layer is actually just one line here. So here, yeah, subtract, multiply, and add. It's just, yeah, just one line of code. But in TensorFlow, we have to write it in this way. And that's it. So this is just the three the 3 value layers, and its diagram looks like, yeah, this. And when you increase the number of this, yeah, 3 to some more general n, then it's much more complicated. But basically, yeah, this is the deep hedging translation of the original problems. Okay, so okay, now I think, yeah, this is a good time to talk about the Asian options. So you know the basics, and I already sent you the code. So you may, yeah, see the code and see the result and compare them to get some more insights. So Asian option. Asian option also has, yeah, 2 different types. One is call options and one is put options. So call option has a payoff of this form, S average minus K0. So in the plain vanilla option, this part was ST, which means the last value of the underlying assets. But the Asian option is just the average of your path minus the strike price. Okay, there are 2 parts. What is the price of the Asian option? And what is the idea to incorporate the deep hedging technology in the Asian options? So is there an idea? Okay, the first, price. You know the binomial option pricing formula. So here is S. When it goes up, it's U times S. Goes down, it's D times S. When it goes up, it's U square S, U times D times S, and it's D square times S. So here is a call option, and I don't know the value at here, but I know the value in the last one, because in the plain vanilla call option, this payoff was ST minus K0, the maximum of these 2. And once we calculate the last value, then we are able to put the risk neutral valuation formula to calculate the current price of the option. And the same idea applies to the Asian options. What is the last payoff of in the last node? Instead of ST, you need to calculate the average of this path. And then, so for example, let me do numerically. So it's 100, it's 90, 110, 100, it's 80, 120. In order to calculate the Asian option price, first we need to calculate the last three values. Let's suppose the strike price is 100. So in order to reach this point, the average is 100, 110, and 120. So I think the average is 110 minus 100 times 0 times max. So the payoff here is 10 instead of 20. And you can do the same thing for the second node. So in average, it's, I don't know, there are two paths, but you can calculate the average. And then that average minus 100, 0, and max. And you on the last node, you can calculate the average of these three, and it's 90 minus 100, 0, and max. So if you increase the number of nodes, the value will be more accurate because, as you increase the number of steps, the value will go to converge it to the original value. But there is no explicit formula. But you can still use the binomial option pricing formula to calculate these Asian option values. So once you have that Asian option values, then you can apply your values to here, the premium. So later you need to run this code. This premium is actually the option price. So you put the option price. So remember that our example, the price is 2.28, but in Asian options, you need to calculate your options and then put it here. And the rest is actually the same, because even though you don't know the delta of the options, it's neural network. So it will try to find the best, not the best, but it is trying to find the hedging strategies for you. So in this example, it does not know. For the Asian options, you have to take care of this part. So this payoff here is for the plain vanilla options, but for the Asian options, you need to replace this part with some average of your value. Let me explain a little bit more about this part, because at first it looks like really complicated, but actually it is not that bad. It says 0.5 times absolute value of x minus k plus x minus k. The reason why I write in this way is that there is no way to express this part in TensorFlow. So TensorFlow does not accept the arguments like this. and this axis is actually it's the ST. So mathematically, these two are same, but it has a max operator. But the author of the deep hedging, they knew that this cannot be expressed in the TensorFlow, so they just modify the formula. And if you calculate this value when ST is greater than K and ST is less than K, then actually you will get this same form. So this is just another way to express this part. So all you need to care about is that how can you replace this average part into something like this. So that's the way you can show the hedging of the hedging of the Asian options. And all the other parts are exactly the same. So this is a very good question. So what part of our code embodies the idea how price depends on time? And actually, there is a much better idea if you are not, if you don't want to bother to translate this part. If I say this is almost the answer. Okay, we know how can we generate the values, right? And for just plain call options, all we need to know is this one. But how about the Asian options? We need to know max S average minus K, comma, minus K, comma, 0. How can I know this average? Since you generate this part, at each time, you can calculate the average. And at the final step, you have the average of all values. And then just use that value to have this payoff. So this is your underlying asset movements. And this is just for your calculation. And you can make these sequence, because you are the developer of the code. So once you know this value, you can always calculate this value and use it properly. Then you are able to hedge the Asian options. So that is the hint for the Asian options. So there is no difference between the usual options and the Asian options. They just need to know how much we need to buy or sell the underlying assets. And that part, the delta part, is estimated by the neural network. So actually, the neural network does not know whether it is an Asian option or whether it is just a plain vanilla options. All we need to know is the final payoff and the price of the options. So for the price of the Asian options, you can use the binomial option pricing formula, and the final payoff, you pre-calculate the average, and then apply that average to the code. Then, so those are just two parts you need to modify. But that, okay, I'm going to accept your final paper as soon as possible, but not from today, because you need to think about it. So probably I can open, it. So this is today. I'm going to open it on June 8th, because this is the start day of your self-study. And then the final due date is 21st. Okay, how can you calculate the average? Well, you need to think about it, because let's think about it in a very simple problem. So let's say you have a numpy array. You have an numpy array. Say NP array 1, 2, 3 up to 10. So this is your array, and if your final is okay, now you need to calculate this one. Is 1, it's 1.5, you need 2 up to this part. So how can you write a code from A to average? Just take 1 and take 2 and divide by 2, take 3 and divide by 3, take 4 and divide by 4. So that is going to be your code. Yes. So actually, it depends on the contract, but this is the Wikipedia page of the Asian options. So this is just the explanation of the Asian options, and it is a short history where who studied the Asian option first. And what I ask you to do is the fixed strike Asian options. And it said its payoff is max A0T minus K, 0. So this A0T means the average between 0 and T. So that means we are going to use the first number to the maturity numbers. But there are lots of different forms, so that the average period is different. So all the other things looks very complicated, but all you need to know is actually this part. This is just the average minus K, 0. For your information, So this average, I want this average to be the usual arithmetic average, because there is another type of averaging called the geometric average. And in this case, Asian option has its explicit formula. But geometric average is, you may try to exercise, calculating the geometric average and calculate the option price. Then you can compare your numerical result with the explicit formula. But I don't need this part. But if you want, you can add this part to your final paper. Oh, okay. Okay, Asian option, we do not know the delta of the Asian options. Of course, Asian option should have a delta, but we do not know the formulas. So we are going to use the TensorFlow. And the basic idea is to use the average value. But not just plugging average value, everywhere. So just think about what you are going to do, and then do some experiment. And then if everything makes sense, then write a paper and send it to me. Calculate the so why is there a price included? Oh, okay, in the TensorFlow code is actually if you read the TensorFlow code, it is not for calculating option price. Rather, the TensorFlow code is trying to verify the price is correct. So that's why the TensorFlow code has a price inside the formula. So let's see. So in this formula, to verify that this is working, is something like this. It calculates your delta hedging or the deep hedging minus price is equal to 0. So this is the TensorFlow code is actually trying to answer these questions. So this is your objective functions. So try to minimize this one as much as possible. So that's why you need the price in the code. So you may think, this is a little bit strange, but it's not to calculate the TensorFlow code is not for calculating the option price. Instead, it is a verification code for that option price is correct by showing that the difference is actually close to 0. So this is a very good question. No, it is not, because the pricing of Asian option. So you may think, that there is an option price, but okay, as I said before, if you use the geometric average for your average part, here the average part, if you use the geometric average, then there is a formula. So that is the a formula if you are using the geometric average. But what I wanted to do is for the arithmetic average. So what I said is you can verify your answer with the geometric average, but for the arithmetic average, there is no explicit formula. So you cannot use this formula for arithmetic average. Yeah, the TensorFlow does not have the average functions. So you have to calculate the average somewhere else and then use that value. You should not use the capture. So you have to type. But if you see the examples that I showed you as a final, so it's on GitHub. No, it's not a GitHub. Yeah, I'm sorry. So this is the example code that I showed you. And actually, his length is less than 15, but it does not include any code because the code is somewhere else. So he made his own page. And then put the model here. So it's if something is really informative, then you should include your code in your final paper. But I don't want you just to copy this part and then put it in your final report, because this is now for us it's well known, so you don't have to include this part. I don't care because I don't want to see your code. I just wanted to read your paper, and if I have some questions, then I may ask you to send your code to me. But usually I do not check your code, so it all depends on your coding. That's for the English lecture students. There is no need to submit your homework assignments. For English lecture students only. for the Korean the lecture students, they still need to submit the homework. So if you want to add your midterm paper, yeah, then that's fine. But I don't see, why do you want to include the midterm paper? Because if you explain the deep hedging with the Asian options, it will be well over 15 pages. So if you wanted to add the midterm paper, that's fine, but I don't see why you need to add this one. So deep hedging and Asian option, and you cannot use the Blackjack formula for the Asian options. Oh, I think, I answered this part. Okay, so I think I answered everything. Okay, it's almost 4 o'clock. So I'm going to wait until the 4 o'clock. If there is no questions, then I will just stop here. But if you have some more questions, please send me your questions in bmenti.com. Okay. I think it'll takes about 2 hours to upload this lecture, because the Zoom needs to process this video. So I think probably I can upload around 6 o'clock. Okay. Thank you. I think, that's all for this semester. And I hope you enjoyed my class. And I hope you are doing very well on your final and to have good grades. Thank you for listening. Yes, for the Korean, you have to submit your homework. Oh, okay. You are in the English class, but you are a Korean. Oh, then you don't have to submit the homework. So that's for all English class students. You don't need to submit the homework. 코드에 넣을 때 각각의 평균을 직접 넣어서. Yes, you're right. So important thing to remember is that it only depends on the final at the maturity time. So what is it? It all depends on. So let me say this is the European type options. So it only depends on at maturity period calculations. So whether the average fluctuated during before the maturity, it doesn't matter. Actually, there are 2 classes, and so you can check your code. So if you are in ECO 311902, then you don't have to submit the homework, the last 2 homework. And if you are in the Korean class, then you still need to submit the homework. So if you're an exchange student, then probably, I don't know, yeah. Then yeah, one good way is always try to submit the homework. I think, yeah, I answered this. Okay, thank you for this semester, and yeah, finish your final as soon as possible and enjoy your summer break. Thank you. Yeah, thank you. 예, 수고했습니다.